product testing round.
How's everybody this morning? Oh man, we're going to need a lot more energy. It's too early. I've only got one cup of coffee in me on the drive up to Salt Lake this morning, so I'm going to need everybody's help to make sure I don't fall over here early. So we may have to get up and do some jumping jacks. Maybe here 15 or 20 minutes, but hopefully we'll have a good dialogue. Hopefully this will be more of an interactive, kind of not full Q&A. We've got a couple questions for us to go through, but thanks for getting up this morning and spending some time. So I hear outdoor product design and development. How many kind of soft goods, jackets, tents, gear, how many soft good folks we have? Okay, who's the gearheads that really like the hardware stuff? So hardware, you know, skis, boots, skateboards, mountain bikes, all that other stuff. So a good mix. Who really doesn't know what in the world they want to do? It sounded fun. I had a friend in class and I just showed up. Anybody still kind of figuring it out? That's okay, because that's part of my role. Kind of how I ended up here. So again, my name's Aaron, based down in Salt Lake as the Instron Senior Field Engineer Account Manager for Instron. Anybody familiar with Instron before this morning? Perfect. We'll start from ground zero and give you just a little bit of background. Don't want to bore you, and hopefully this won't be a full PowerPoint presentation. So we'll kind of breeze through a few things and then have a couple of kind of case studies, kind of discussion topics towards the end. A little bit about me. How in the world did I end up here at Utah State on a Friday morning? Yesterday I might have dressed up, but today we'll put on the official Instron shirt. I grew up in Oklahoma, University of Oklahoma, mechanical engineer by schooling, electrical engineer by osmosis, I like to say. Electric race car team back in school. So the double E's wouldn't let me wire anything or actually solder anything, but at least got to look over the shoulder and play around with electric race cars. So solar cars, electric IndyCar program. Really cool stuff, a little bit different from the design you all are going through, but similar paradigms, kind of the idea of just make something on paper, get it in the parking lot, make it go putt around the parking lot for a little bit, and then hopefully, eventually we race it and see how it shows up. Maybe we fail miserably, maybe the thing wins and we go out and have a big celebration there. All of that in the learning process, just having fun. Through that process though, I actually am probably one of the, we'll say 5 people in the history of the world that started off in engineering, quit engineering, and then decided to come back to engineering. I just said, man, I don't know if this engineering stuff is really for me. Freshman year, I was walking around back and forth past the library, and the same people were sitting in the same desk for what seemed like weeks on end, sitting there with a calculator just crunching numbers. And I kind of had this big, ooh, that's not what I want to do with my life kind of moment. I had a friend that worked in Colorado, so took a semester off, went and bumped chairs at Keystone Ski Resort in Colorado. Did the ski bum thing for a little bit. Decided, you know, engineering was really cool. Luckily, I had some folks that kind of pointed me into some of these programs, the electric race car stuff that got me into the cool part, not just the tedious weed out part. So seeing the light at the end of the tunnel is super important for me. And if at any point you find yourself in that realm of, I'm not sure if I see the end of this process or the light at the end of the tunnel, ask somebody, talk to friends, talk to faculty, everybody's there to help. And I didn't do that early enough in my case. But I came back, went back to school, got my degree, and then decided, you know, I can work for the rest of my life. I'm going to go back, drug a couple of friends up to Colorado. We went and bumped chairs again, stayed for the summer, and then moved to Texas for a couple of years out of school. So started off as an application engineer, tech support, test and measurement related, a company called National Instruments. Spent about 15 years with National Instruments in, well, 3 years in Austin, and then moved out to the field in Tucson. Year and a half there, got too darn hot in the summer. Moved up here where my wife grew up in Layton, but we're actually in Utah because I like to ski and mountain bike, which is denoted there by the last bullet. Started bike racing pretty much right out of high school. Didn't have the NICA high school racing program at the time, so it was just a bunch of us in cut-off jean shorts, Basque hiking boots, rumbling around the woods, getting dirty and having fun. And that turned into just kind of a lifelong love of endurance sports and racing. So I've been doing that off and on. We'll call it a semi-pro. Used to be an official category with USA Cycling, but never had a real pro license. But for open races like Park City Point and others, I'll race with the fast kids. Not quite as fast. If anybody follows bike racing, Keegan Swinson and Those guys, not quite at that same level. I figured out early on I could maybe make $100, a couple $100, and spend a whole bunch of money traveling around to races, or I could get a real job, and I could do the racing thing for fun, and occasionally maybe make a little bit of money, or at least have a real job to travel around and do races like the Leadville 100, which 2018 actually became the second person from the state of Utah to actually go under 7 hours. So Alex Grant was the first one. I managed a 6:59.40. So of all the things that happened over the course of 7 hours, one of which was a crash at the feed zone when a musette, which for those that don't know, musette's a bag cyclists put their bottles of food in. Usually you ride by, well-oiled machine, you grab it, you throw it over your shoulder. Well, my buddy that was handing it to me was a runner, hadn't handed the musette to a cyclist before, and he kind of was on the wrong side. So I'm rolling in, figure out, right hand, I can make this work with the left hand. At the last second, he leaned in, bag hits the tire, I go down in the dirt, and luckily only lost maybe a minute, 2 minutes. That came in 20 seconds under the gun for that 7-hour mark. And then last year, actually, Bryson Perry, if anybody else knows him, he actually became the third guy. So fast some days, not so fast other days, but kind of keeps me fit, keeps me out playing, and also gets into the product side of things, which we'll get to towards the end. So that's me. And Instron, I ended up, after spending about 15 years with National Instruments for data acquisition, instrument control, still in the test world. So when we get to the idea of testing a product, we'll circle back to that towards the end. Been with Instron now about, since the spring, about 6 months. Spent a little bit of time doing industrial automation for about 3 years in between, and it brought me here. Instron, been around since 1946. Two founders from MIT doing essentially what you guys are looking at right now, outdoor product design, parachutes. In this case, had some military applications. Trying to figure out different substitutes for silk thread for parachute cord. Nothing existed at the time that was accurate enough, fast enough to actually make the measurements to help them validate these other materials that they were looking at using for parachutes. So they invented their own. Instron, what's now kind of referred to as a universal test system, or UTS, is essentially just a machine that tests the mechanical properties of materials, whether that's cord and yarn for parachutes or fabric, composites, a lot of other things. And today, since 1946, we're the leader in universal test systems. So 96% of Fortune 500 doing product tests have used Instrons or have Instrons in the process. There's other systems that we complement, and we're not the only company for tests. But several you'll see, a few which you've already visited or maybe had discussed. I didn't want to take the license and just throw a couple of logos up there for several reasons, because some companies like to keep that themselves. And we'll talk about a few, one of which, teaser, there's an icon up there for a company that we'll talk about here in just a second. So you've developed a product. Congratulations, you got this product off the drawing board. Got a prototype. Why in the world do we want to test it? This being the interactive portion. Or at least the first interactive portion.
You don't want your product failing on somebody in the middle of like a race or in the middle of use.
Don't want it to fail? Perfect, exactly. And somebody else, definitely a big thing. You might be the one testing it yourself. Probably don't want it to fail on you if you're doing this in the garage and figure out if it's going to work.
You can continue to make improvements on it.
Definitely. Continuous improvement. Back to this side of the room. Why would you want to go through and test something? You just need to test it once.
See the longevity of it.
What?
See the longevity of it.
Longevity, so in terms of
how long the product will last.
okay. So how long the product's going to last? Breeze past this guy. Anybody been on North Face website? I think it was last year, maybe 2 years ago. They actually just relaunched and showed up on Backcountry, I think, with the fashionable red color there. So circa 1996, I have some other flashier jackets that predated that red and black one, but that actually is so what I blow snow with. It's still over 20 years later, and that jacket's still going strong. A little bit big, so I don't want to ski with it, but yeah. How long is this going to last? What's the fatigue life? All those things. So, teaser, or I guess hint, first response from the audience is kind of one of the reasons. So, what in the world is 75 million over 5 years plus 20 million over 2 years? And this is a question primarily for the soft goods folks. You paid attention to sports sometime last spring. Any guesses? Who makes $75 million over 5 years? I'll give you another hint. This is an individual person. This isn't a company. Do you think any of the products you might design could get somebody, or convincing somebody to use your product over this time span would justify that amount of money? Any basketball fans in the room? Okay. Any football fans? Because I hear there's a big game up here tomorrow.
Yeah.
So last spring, Duke University, North Carolina University, big game out in the Carolinas. Within the first, I think it was 90 seconds, 60 seconds, Zion Williamson, a freshman basketball player, goes down making a cut and blows out his assumed brand new pair of Nike sneakers. Tears up his knee, he's out for about a month. Finally came back during the NCAA tournament. So Zion went to the draft, came out of school after 1 year, and those numbers, 75 million over 5 years is his Nike contract, or specifically the Jordan brand. So even though Nike fumbled a little bit, and whatever happened here may or may not have been tested, that might have just been a quality thing, might have been just a one-off. That might have been a prototype shoe that they made some changes and it just didn't quite go through the right process before it got put on his foot. Or you look at this guy who, I don't know his exact weight now, but I'm guessing probably over 200 pounds, big guy, power forward, he puts amount of force, different from what I can do, different from what my wife grew up playing basketball. She's 5'2". She's not going to put the same amount of force on that tennis shoe. So testing allows us to mimic and validate material properties, individual characteristics of all sorts of things. Taking that from an individual material, the adhesives between the shoe in this case, to the actual product. So testing, in the case of metal, say fatigue life, I'm guessing it's probably aluminum. See the same thing in titanium if you were to search for bicycle cracks and frames. Over time, stuff can break. If you think about any four-wheel drive folks in the room, like to go out on some dirt roads and kind of bounce around a bit, stuff just kind of rattles and shakes. Over time, that can wear, it can rub. You get different things can happen to the product if it's just sitting on a desk versus rattling around or in your backpack or out on the trail for backpacks and other kind of gear. Climbing rope. If you rub that rope over the edge of a rock, which inevitably is going to happen, how long is that going to last? At what point, what's the lifespan of that particular material? And can we design the sheath and other things about the cord and the yarn and all the things that go into that construction to make it more durable? Or is your design goal, this is going to be the lightest, the fastest, the quick approach, very streamlined piece of climbing accessory to help somebody like Alex Honnold go set a record, and we're only going to use this once. That's a design consideration you know up front. All of those things, whether it's lightweight or strong or cheap, those are all considerations, but typically you can't have all three of those things. And a cam, looks like that's probably been through the ringer, been beat up a little bit, maybe got bashed around the back of somebody's trunk. That's the last thing I would want to have happen if I'm on the end of the rope. Hopefully have some additional protection to save your bacon as opposed to hitting the ground. But figuring that out, testing that in a lab, would at least help the manufacturer, whether that's Black Diamond or Petzl or somebody else, help them understand what are the characteristics, at what point, what's our recommendation for throwing that away. Carbon fiber rim. Manufacturer we won't mention, but that's actually a friend of mine who's actually 63 now. Still racing bikes, still winning bike races. He hit the very last rock, like literally the very last rock from dirt to pavement after a 50-mile race in Carson City, the Epic Rides Carson Off-Road. Bashed it, went from first place, had a flat, luckily passed it up, ended up in second place, but he hit a rock. He's not much bigger than I am, not something where that should have failed. He just hit it just in the right way with probably a little bit too low tire pressure, and away we go. He was on the side of the trail, watched first place go by him, didn't quite get the same prize money. And then that's actually my helmet, a Specialized Prevail that saved me from a concussion or worse when I actually fell and shattered my right hip 4 years ago down in St. George. So impact, what's the Snell dot rank ratings for, say, helmet? That can help minimize injury, make sure that the protection that you're designing into a product actually does its job when it's called to action. Hope nobody actually has to put the helmet through the ringer, but most helmets that you're going to get from reputable manufacturers will do just that. They're going to crush, they're going to break, they're going to keep your noggin intact. Those are more on the breakage side, but why else would you want to test? You're designing a product, you have this really cool design that looks fantastic on paper, or today in the computer world you have it drafted up, or whether it's Adobe Illustrator or some other tools you have access to. You now prototype that, but what do you need to do to make sure that that really cool looking product is going to be functional? Or that new material that you have is actually going to do what the scientists and the product designers, the material science folks actually say. Well, maybe you put somebody on a treadmill and you crank up the heat, you turn down the temperature, you change all sorts of environmental factors to make sure it breathes, make sure it does all the things that you might want it to do out on the field, or out in the field of play, or out in the backcountry, you name it. Aerodynamics, big thing, especially coming from the engineering side. That's the Specialized Wind Tunnel out in Morgan Hill. And behind the scenes, actually the company that I started out school with, National Instruments, actually has the control systems for that, actually controlling all the fans, controlling the speed, the data acquisition systems that are making the measurements for hard goods, for bikes, for wheels, for the clothing. If you get on the Specialized Wind Tunnel feed, post a question, they'll look at what's the fastest or best set of clothing you can wear for, say, the Dirty Kanza. Everybody heard of the Dirty Kanza? 200-mile gravel race out in Kansas. Why in the world would anybody want to go out to Kansas and race bikes? Well, having grown up in Oklahoma, there's a whole lot of cyclists out there as well. They don't have the mountains, but there are these rolling hills that are just beasts. And over 200 miles, you still want the same kind of aerodynamic benefits you might get on a fast road bikes for the Tour de France. So they have a video of one of the leading ladies going into the wind tunnel and figuring out where to put the bottles, what helmet. Is there a difference between a Camelback style hydration pack or bottles on the frame? Tools, where do you put the tools? All those things may not matter for the weekend athlete or just somebody going out for an easy bike ride, but for somebody going and spending a lot of time on a product, even if you're not getting paid to do that, there's plenty of folks that like to have good gear, like to go fast, want to figure out the best way to do it. So we hit through a couple of these. Proven design. Fantastic reason to do the first step. So you're prototyping, you're designing your product. You want to make sure this product you've just come up with is really going to do, one, what you want it to do. Two, you haven't designed something that is just not possible to create. Less of a consideration today because, man, you all have access to so many cool, powerful tools that the designers that came before you didn't have access to. 3D printing of composites today. Back in the 20s, 30s, 40s, architects would have fantastic designs, these really cool buildings they could build, no way to really actually manufacture this because the technology hadn't caught up yet. Nowadays, you can prove that out, and in a matter of a day, maybe even half a day, prototype something, come up with the usability. Are the buttons in the right spot? Is the zipper in the right spot? Something that might have taken weeks or a couple of months to actually turn around. So how many shoe designers or future shoe designers we have? Okay. how long would you think it would take a major shoe manufacturer based in Europe with factories in Asia to turn around a prototype from sketch on paper, get it manufactured, get it back in the offices in Europe? Any idea how long that should take or it used to take? 2 weeks. Okay. We price is right? Higher, lower? Anybody? Anybody think you could do that in a matter of maybe a day or two, just whatever the shipping is? Turns out, in years past, that major shoe manufacturer, we're talking months to turn around a design. Piece of paper, that sketch, it's not digital at the time, it goes over, gets sent to the factory comes up with, here's I think what the designer has in mind, puts it in a box, ships it back out, that shows up in Europe, may or may not be the right thing that the designer had in mind, so maybe there's some iteration, so we're talking at least a couple of weeks to turn that around. Where today, that same shoe manufacturer digitally designs it, sends it over to the factory has kind of just-in-time custom manufacturing capability, can stitch the product up, form it up, and then whatever the turnaround time for the stitching, the adhesive curing, the sole of the shoe, can turn that around, and we're talking a matter of days now, so they can get it shipped back. So the iteration process, to go through and iterate on the design and come up with something that actually is working, figure out what the design flaws might be, where to move fasteners, etc., I think it's a whole lot faster. Where the Instron side of things comes into play is really the characterization of the material itself. So in that shoe, you've got the sole, you've got the tread material, you've got the foam, various different materials that go into the sole itself, depending on the cushioning, depending on if you're a pronator or how your foot actually performs, how your knees alignment, all those different things. And you have the upper, so the insole as well. Lots of different materials go into that shoe. So very much like a composite mountain bike, carbon fiber and other things, it's still a composite product. You have all these things working together to figure out or to come up with the characteristics of what you're trying to design, whether that's a super light, super fast ultra marathoner shoe to go set a world record for the marathon, or something that's going to hold up to years and years of use out in the backcountry and actually be durable, maybe a little bit heavier, but also going to last a lot longer than that pair of ultralight marathon shoes. So the life expectancy, once you've actually taken that design, prototyped it, checkbox, and man, this is what we're going to actually bring to market. Now we need to validate that what's coming out the door, or coming off the line of production, is actually meeting the expectations and quality standards you've set, which is back to that Zion Williamson shoe. Who knows? I'm sure there was an investigation and Nike convinced him that are bad. They actually took a pretty, well, not a huge hit in their stock that day, but they bounced back. Whatever problem was, they still signed him up because the Jordan brand, as you might know, is part of the Nike family, so they didn't really lose anything on it. Maybe had to give him a little bit more money in there. I think he was estimated to get $10 million a year, ended up with $15 million a year. Some of that might have been because they took him out for a month or so. But now that you have that product to market, you can move on to the next thing, so that iterative design. All sorts of products, pretty much anything and everything that you touch or use has to be tested somehow. Whether it's the chair you're sitting in, how much force can that chair withstand? The fabric in your jacket, fabric in your shoes, how much force can that withstand? Tearing, what's it going to take to actually tear it? If a tear does happen, you brush into a tree or catch a cord or something sharp, is that tear going to propagate? With my down jacket, am I going to end up with feathers flying everywhere, or is that small hole going to hold itself together and I can actually patch it up? All the way down to the adhesives, zippers, the fasteners, you name it. If it's something physical you can touch, it has been tested by somebody. All sorts of little things, the paper, the pen, what's the force is. In the case of other industries, biomedical applications, for instance, auto injectors, one of the big things now with syringes and other things, what's the force it actually takes to actually poke into your arm to make sure that that is something that even a kid can use. So all of those things that are tested at a material level, typically in this universal test machine that I mentioned before. Tensile test, essentially pulling on things. Compressive test, pushing it together. So maybe that climbing rope, a tension test. You know, you compress the climbing rope, it's just gonna act like a wet noodle because there's no structural integrity of that. However, the foam in your shoe or the loft of your down jacket, what is the force actually required for that? More so maybe in a sleeping bag. How much loft when you actually lay on the sleeping bag does that have? What's the insulation characteristic? Sleeping pad, etc. Actually saw, I think, one of the projects from the last year or two, the hammock tent, which I don't think was the official name they came up with, but you put the hammock tent, how much weight can you put in the tent? What's the wind going to do? So once you have the material properties, you might get into some other environmental testing, which may or may not be at the individual material level. It definitely happens that way, but you might want to do that as a full product. Have a chamber where you're splashing it down with water. That water might be just regular fresh water, salt water if you're going to be in a sea environment, temperature, humidity, all sorts of things that you can do. Whatever comes to mind, you can set up a test, figure out if your product's going to actually withstand it and work the way that you want it. Really, two primary ways we do material testing. Static, kind of shown over here, where it's just that tension, compression, peeling. So if we have, say, an adhesive peel, just like with the top of a yogurt, you grab it, you peel it, how much force does that take? And is it going to peel consistently? One of the things that still bugs me to no end is you go to the store, depending on where, say, a jar of almond butter was produced, jar from Walmart opens differently than the same manufacturer's jar sold in a different grocery store because of the manufacturing process. So the quality of just that peel, if that factory that's making your shoes in Asia, in Central America, in the US, are the characteristics and the qualities of all those manufacturing processes the same? Or are they different? And if they're different, you might need to change the manufacturing process to work with the team there. On the other side, dynamic testing. So the fatigue, the lifespan. Rather than just simply pulling something until it breaks, that's actually one of the Instron dynamic systems. There's other companies that actually make larger scale, or you can come up with custom things. You might see down at Black Diamond, they actually have some very custom rigs for doing the cycle fatigue testing on various different climbing products. But the idea is rather than pulling something to failure, we just want to sit there and shake it. Take that cam, open the gate. Take the material that's going to be in your jacket, keep stretching it over and over and over and over. On the bicycle, Specialized has a lab. In fact, for counterfeit parts, one of the things that Specialized and other manufacturers have a tremendous problem with is overseas counterfeit product, where it looks like it's an honest-to-gosh Specialized bike or helmet or you name it, but functionally it has none of the structural characteristics. So they'll put a bicycle frame on a jig and essentially simulate a sprint. So somebody like Peter Sagan or Tour de France rider that can put out 1,500 watts, maybe 2,000 watts for some of the pure sprinters, they'll do that over and over and over, I believe for 14 hours. So it's essentially a full-on sprint as hard as you could go for 14 hours at a professional elite level, just to make sure that their product's going to last. They find that their design product comes off the rig, it's still fine, hasn't cracked. You find a counterfeit product, and at some point it's going to break. Sometimes it breaks quick, sometimes it breaks later in the cycle, but it's going to break at some point, just a matter of where to find it. Testing on raw materials and specimens we already talked about. Up here on the side, typically when we talk about specimen testing, what you'll find from the material science folks or the engineering team you might be working with are individual coupons, or what we call a specimen. So in test, the specimen is the individual item, whether that's a piece of yarn, in this case maybe individual filament, or a set of fibers, what we'll call a tow for composites. So depending on the product, the number of fibers in that little string. Or on the fabric side, an individual piece of fabric, that's the specimen. And then a sample is the group of specimens, just in terms of nomenclature. When you put that together in your product, whether that's a prototype or a release product, then you can do component and system level test, which we can do, as well as that might be something you have custom set up. We talked about tension and compression, shear, flexure, some other things, measurements, lots of different data. Camera, certainly something that would come into play here, especially for the long duration testing, the life cycle type things. Want to see if it fails, when it fails, and what happens when it fails. So does that crack explode? Does it yield? Won't bore you with the engineering details, but stress and strain are something you'll find. The tensile stress, your tear stress, tear strength in fabrics. These are some engineering terms that dive into the test. But functionally, strain, just the change in length over the initial. So it's just kind of a measure. Here's how it started. We applied some force. It moved. In the case of what we call a ductile failure or ductile material, silly putty is kind of a really ductile example where you pull on it, it's just going to pull and pull, versus very brittle composites, carbon fiber fall into that, rather than yielding, or this idea of you pull it and it's going to stretch a little bit and then pop. A brittle failure, something that's very rigid or a little bit more stiff, that's going to push on it or pull on it, and all of a sudden it's going to fail catastrophically. Aluminum falls into that category, composites as well. So it's not going to have a slow death, it's going to have a very sudden and immediate death if it fails. Kind of like with the coat hanger. So in terms of strain that's elastic, you grab the bottom of the coat hanger and you just pull on a little bit, let go, it goes back. Pull on it too far, at some point, you've now deformed the metal of the coat hanger. Pretty much every material has that property, with varying things that can happen. The rate at which you pull on it. So in the case of, say, a pair of skis that you're bombing down a mogul field in a World Cup and doing very quick, very repetitive force application, as opposed to a 6-year-old on a pair of skis, the rate at which that force is applied is different. Same thing with the downhill mountain bike or a cross-country mountain bike. Somebody jumping out with a parachute, pulling the ripcord versus that same material. The rate at which the forces are applied can change how your material behaves. That's something you would maybe pick a different material depending on your application. Same with the temperature. Sometimes things that work here in a room that's temperature controlled don't work when it gets cold, or don't work when it gets hot. So understanding the temperature characteristics are quite important. And then depending on where you're actually selling your product, you're going to have some other industry standards that might be important or required. So ASTM is one that you'll typically run into. You get into climbing gear, for instance, CWA or UIAA down at the bottom, are industry standard bodies that define types of testing. So all this stuff is defined in a huge set of documents, 11,000 and going strong set of standards for ASTM, for instance, for the North American market. If you got on the link at the bottom, just ASTM.org, for anything and everything sports related, it goes through, here's exactly how you test the shoe. Here's how you test that fabric. Here's how you test a bicycle part. Here's how you test the helmet. So not something you have to come up with on your own. There will be a team that you're working with that will identify, here's what we need to do to test. So in the last couple of minutes, I'll wrap up and we'll leave some time for questions. During the design process, what I would encourage you, and probably will be the case in most of the companies you might go to work for, is on the design side, involving the engineering, the manufacturing teams early on, so you come up with the feasibility of, hey, you had this really awesome sketch, really cool idea, we can't make it. What you're asking to do just technically doesn't work, or we may want to try it, we can initially prototype it and come up with the, does it look, does it feel, does it actually kind of function how we really want? If that works, move on down the process. But having the team involved is so critical to being efficient through this process. And then coming back on the end, at any point, you can kind of jump back to the design and find out there's something that needs to be iterated on. So rather than designing something, the old school idea, if you design it, you throw it over the fence, somebody figures out how to manufacture it. Like back to the shoe designed in Europe, sent over to Asia, sent back. That thrown over the fence is just inefficient. And I expect fully you all have already seen some tools to make this a little faster here, and will be much better, more efficient once you get out in the real world designing your products. But certainly including folks on the whole team as part of that process, so you can be more efficient. So in the last couple minutes, I have 2 small case studies, or not really case studies, but a couple things. So any idea what 132826 is? A little bit less than that $75 million number.
1997 Honda Accord.
Say what?
1997 Honda Accord.
Very good guess. Probably could have been the same. That was actually the biggest check that I wrote as a sophomore in college. Most amount of money I'd ever spent at the time. For the mountain bike I saved up all summer for. That was the first real race bike that I bought. Steel frame. I had to add the forks separately, the Shimano XD parts. You'll notice for the soft goods folks, that's a cotton t-shirt, cotton pair of baggy shorts. I think Under Armour, when they were talking, figuring out that cotton under football jerseys and football attire is not the best, especially in Oklahoma in the summertime. This was actually in June. But man, $1,300 and change, that was a lot of money, which still is, but well, I didn't, you got the teaser. So 20 years later, or about 25 years later, a hardtail that just got released. Part of racing and knowing some folks in the industry. Thankfully I didn't have to spin that. They gave me one to ride for Leadville and then the barn burner. But almost $10,000 compared to $1,500 20 years ago gets you 8 pounds lighter. I think that hardtail that I had was 27 pounds maybe. This guy out of the box, like 19.5 pounds for a large size frame. And if you're designing that for the hard good folks, what do you need to test in this top end, or even maybe a step down, same set of components? We've got composite carbon fiber frame, fabric on the seat post, or on the saddle I mean, carbon wheels, we've got metal in the spokes, CNC machine cassette, wireless, something we haven't talked about so far today. We've been focusing on materials. Wireless communication, everybody has a phone. That wireless communication is some RF signals or radio frequency signals that are talking back and forth. In this case, the SRAM parts, it's a proprietary format, but it's very similar to Bluetooth or other things, or ANT for the cyclists, or the fitness monitors, the ANT Plus protocol. Similar idea. But as a designer, you might have some considerations that aren't just product focused or usability or material focused. Are there things that I design in my product that are shielding some of the electronics that cause communication problems? All that's part of that design process, so working with the engineering teams. So a lot of different things that would go in to the product in terms of design, and various steps of test along the way. Now in this case, for a manufacturer where you're getting components from other suppliers, you may not need to test all of this. If you're working for Specialized or another bike manufacturer, you expect that the drivetrain supplier, in this case SRAM, has tested those parts. You don't need to test it on yours when it comes to the factory. But somewhere along the line, SRAM did some communication, testing, validated that part, validated it works, probably got it in the hands of some of their pro riders out on the World Cup circuit to make sure that it works. It's going to not have crosstalk communication, because the last thing you want is somebody on a Tour de France team, because they do have a road version of this as well, a Tour de France rider trying to shift in a sprint, and somebody next to them is shifting the other direction. They're crosstalk, they have some other problems, and all of a sudden, it's kind of like you're driving down the street in your Tesla with auto driver, and it slams on the brakes, and not what you intended. So validating all those things, very important. In the case of brakes, their latest version, I will say, worked quite well, but anybody have a pair of the original SRAM XX brakes for the cyclist in the road? This was 7, 8 years ago, so maybe a little early, unless some of your folks or other friends had XX brakes. They came out super light carbon fiber lever, magnesium body, which is a little bit lighter than other aluminum options. But within a matter of actually a couple of hours, mostly a few days for most folks, you bleed the brakes, they would just go squishy and turn into a mess. These are top end at the time brakes, a couple $100 each, and within a matter of days or hours of bleeding the brakes in a bike shop, all of a sudden you're out there on the trail and the brakes aren't working. Took 3 iterations. And this is my engineering side of things. It took 3 iterations for this company to figure out that, in their case, they use dot brake fluid. Dot brake fluid versus mineral oil is the other option. It doesn't compress, same kind of thing you find in your car. But the magnesium caliper in that brake lever, talk to a chemist, any of the chemical engineering folks, you mentioned dot brake fluid and magnesium together, and they said, that's a chemical reaction. So turns out that product, which looked great on paper, tested pretty well, I would expect, but for whatever reason, didn't validate the fact that when you put dot brake fluid in the caliper, bubbles just happen. It's a chemical reaction. So all of a sudden you get a lot of folks that are returning the product and there's still bags and bags of these XX levers at most bike shops around, so we're talking a lot of money for a bike manufacturer. Last one I'll run by you is in terms of soft good product design. It's actually a company based out in Alpine called Cielo Bike Bags. They're now Cielo Pro Bike Bags. If you get on zieloprobags.com, they started making road bike bags about 7 years ago. If you've ever driven around back and forth in the mountains here in the wintertime, you know there's a lot of snow, car gets dirty. If you're like me, you spend some time cleaning a bike, put it on the back just to drive around and get it dirty, wasted a whole bunch of time and effort. Or in the case of driving back from Leadville one summer after Leadville racing, it rained pretty much the entire way from Vail all the way back to Price. And I got back and had about a half cup of water in the bottom bracket of the frame. My bearings were shot. That was, if I had to add it up, probably well north of several $100 of parts that had to get replaced just because they had gotten battered with all the water and the bearings were ruined. So Gabe at Zeal had the idea, let's cover the bike. Let's have some way to protect it from all this other stuff. So I contacted them actually after this trip back from Leadville. Said they had an ad in the back of Cycling Utah. They didn't have a mountain bike bag at the time. It said, man, you come up with a mountain bike bag, I'll get it, and I know a lot of other folks that would love to have one. So they got it out. This is actually on a fat bike, so it turns out it works for both mountain bike. They've got one for road bikes, and then on a fat bike, coming back from, actually that was at Pall Mall for one of the fat bike races several years ago, in a snowstorm. Take the bag off, and the bike's nice and clean inside. Got a light kit, so it actually allows you to drive around the road without getting pulled over. So you can signal and have your lights. So quite functional. Just one of those cases where somebody had an idea, but I don't want to get my bike dirty. Prototyped it. Actually, somebody down in St. George stitched it up, came up with a prototype, and then you get on the website. There's a picture of somebody that actually had saran wrapped a bike on the same thing. Actually, a guy I know coming back from Leadville had some rain. He stopped at the grocery store, got saran wrapped, and by the time they got back to Alpine, it was just tatters and stuff. So, thanks for your time. Hopefully that was helpful in terms of a whole lot of stuff that we can talk about in terms of tests, in terms of product design. Any questions?
We got time for maybe one or two real quick questions. If not, we can have questions outside. Next question.
Well, thanks. Best of luck. You guys are up. I've got one.
You were talking a lot about like custom testing and like testing and stuff like that. Are you guys making, or the testing on black diamond bands? Are you guys making these custom rigs, or are you just making one, like a series of machines for you?
Okay, great question. So in terms of Instron specifically, we have a couple of standard products. We also have an engineering solution group that can do custom. For the most part, most large companies, even small companies, are going to have some level of engineering capability to design and develop custom things themselves, or there's a tremendous number of companies that come in and automotive is certainly a great example for dynos for the engine, various aspects where they'll take all the different components, and that's not an off-the-shelf solution. But either internally, companies will come up with, how is this going to be used out in the field? Let's create a rig, a specialized, create a rig, put some forces on it, that's something that fits their specific use case. So sometimes that's off-the-shelf components, and then putting them all together to create a full custom. So yes and yes. Cool.
I have one other one. Is your logo two guys pulling a rope? Like,
It is.
each other?
So yeah, the pencil test, is that where it came from?